Okay, so today is part 2 of finding zeros. In this lesson, we will find the zeros of a quadratic function with a leading coefficient greater than 1. So today, a is greater than 1. So if you look at our examples, we have a number there. I have again here, because I keep using them interchangeably, zeros, x-intercept solutions. They all mean the same thing. They get used interchangeably. We are going to use the same two methods, solving and factoring, and we're going to talk about when we can use them. On the front side of our note sheet here, all of these problems have b equaling 0. There's no middle term. So it's just the x squared and the number, just the x squared and the number. For this, you can use either method that we learned on Tuesday. So for this first one, 4x squared minus 81, we can solve this. So the steps to solving were to set it equal to 0. I'm going to go ahead and do that. Don't write huge. And then we are trying to solve for x. So we're still going to get rid of the number we're subtracting first. So I'll add 81 to both sides. I have 4x squared on the left. I have 0 plus 81 on the right, which is 81. I didn't say that. Okay, then I need to get x squared by itself. What is currently keeping x squared from being by itself? Or sorry, what's currently keeping x from being by itself? The 4 and the exponent. We want to get rid of the 4 first. So the 4 is being multiplied, so we are going to divide it. So we're going to divide both sides by 4. Okay, we now have x squared equals. We are going to leave it as a fraction. Because if you were to divide this out, you get 20.25. You do not want that. Because we can handle it as a fraction here in a second. Okay, now what's keeping x from being by itself? The exponent, the squared. What is the opposite of squaring something? Square rooting it. So we're going to square root both sides of this. Okay, here's the deal. 81 fourths is not a perfect square, but 81 is a perfect square and 4 is a perfect square. So off to the side here, I'm going to write this down for you. The square root of 81 over 4 is the same thing as the square root of 81 over the square root of 4. So like I can split up the square roots like that. What's the square root of 81? 9. What's the square root of 4? 2. Okay. But I need 2 answers. What are my 2 answers? My 2 answers are the fraction, one positive, one negative. So this would be that same plus or minus. So my 2 answers are 9 over 2 and negative 9 over 2. And we are going to leave them as fractions. So it's the same plus or minus. Because like yesterday, if we would have just had the square root of 81, we would have just said plus or minus 9 would be our answers. So today, it's the fractions, still plus or minus. Any questions about that first solving one? Okay, let's do the other solving one then. We have 12x squared minus 48. We're going to do it the exact same way. So we're going to set it equal to 0. I think this one ends up being easier. We will add 48 to both sides. I get 12x squared equals 48. What should I do next? Say it. Divide. Yeah. So we're going to divide both sides by 12. We got x squared equals. Can we do 48 divided by 12? Yes. So then we do want to divide it out. If we can divide things out, we do want to divide them out. If you get a decimal, leave it as a fraction. Okay? So 48 over 12 is 4. Okay. What is our last step here? square root. So square root of x squared, square root of 4. What's the square root of 4? And also, negative 2. So x is plus or minus 2. You can write that. You can just go straight to your zeros. I don't care. All right, so sometimes you'll end up with fractions. Sometimes you won't. Our goal with this unit is to show you like all of the possible things that might happen. We made this unit a little bit more challenging so that you guys would be a lot more prepared in the future. We used to make it like super straightforward of like, there will be no fractions, there will be no weird negatives. We'll tell you exactly what method to use, but then we realized when you guys get to Algebra 2, you have no idea what method to use. So we're teaching you all the methods and then giving you ways to choose, okay? So, any questions right now about the solving for today? Okay, if you did not like doing that, here's another way you could do it. We could have also factored both of these problems. So this one right here, 16x squared minus 49, 16x squared and 49 are both perfect squares. It's subtraction, so we can use difference of squares. What is the square root of 16? What's the square root of x squared? X. So, my difference of squares is going to be 4x plus, what's the square root of 49? 7. And then my other piece is going to be 4x minus 7. So 4x times 4x is 16x squared. 7 times negative 7 is that negative 49. And then if I were to multiply it out 2 by 2, the middle terms cancel. That's why this special rule works. So with factoring, we now set these equal to 0. And we use the zero product property, which is that if this equals 0, either this or this have to equal 0. So now we're going to set each of them equal to 0 and solve. So 4x plus 7 equals 0. 4x minus 7 equals 0. So for 4x plus 7 equals 0, we would subtract 7 from both sides. I'm going to get 4x equals 0 minus 7, which is negative 7. And then I divide by 4. And I'm going to get x equals negative 7 over 4. And I'm going to leave it as a fraction. For 4x minus 7 equals 0, I would add 7 to both sides. I get 4x equals 7, because 0 plus 7 is 7. I divide by 4. And my other x is positive 7/4. So these ones are a little bit extra to solve out because it's now a 2-step equation instead of a 1-step equation. Okay. Any questions at the moment? All right, we have one more factoring one. We have 12x squared minus 48. Are either of those perfect squares? No. No. Can we divide 12 and 48 both by anything? What? 12. So we can divide a 12 out. So this would be us fully factoring it by dividing our greatest common factor of 12 out here at the beginning. So we'll keep our f of x equals. We're going to divide out a 12. 12x squared divided by 12 just leaves behind the x squared. Negative 48 divided by 12 is minus 4. So this one had a greatest common factor of 12. And now we can factor that x squared minus 4 using difference of squares. So square root of x squared is just x. What's the square root of 4? What's the square root of 4? Okay, let me concern there for a second. So x squared minus 4 can factor out to be x plus 2 times x minus 2. Okay, if I set that equal to 0, I still am using the zero product property. Now I have 3 things that are being multiplied together. Can 12 ever equal 0? No. So we don't really have to solve that one because it's not going to be that. We just have to solve the ones with x's. So we've got x plus 2 equals 0. We'll solve that. And x minus 2 equals 0. Okay, and by the end of Tuesday, you guys are doing a really good job of this. When is x plus 2 going to equal 0? When x is, like, what's my answer from this one going to be? Negative 2. What's my answer from this one going to be? Positive 2. It's going to be negative 2 and positive 2. Because if I were to plug those in, negative 2 plus 2 is 0. 2 minus 2 is 0. All right, any questions at the moment about factoring or solving? Okay, what do you guys notice about the second problem we did on both of those? Yeah, what do you notice about the original problem? Did you even notice? We just did the same problem twice. So this one, we solved it out. This one we factored. 2 ways to do the same thing, okay? So you choose your method. I don't care which you use. I just care that you have one method. I care that we practice today. And then Tuesday, we have a third method, which is a little bit longer of a process and a new process, but will work for every single problem ever, no matter what ever. So, pros and cons. Okay, any questions? Okay, flip this over. We have some other factoring ones on the back. So on the front side, we had the ones where b equals 0, and there's no middle term. If b does not equal 0, you're going to have to factor for now until Tuesday. Tuesday we'll give you another method, and we're going to use the zero product property. So we are factoring these like we factored in 5.9. So 5.9 was when we would find 2 numbers that multiply to AC. So this is A, B, C. So multiply to AC and add to the middle. Then we would split up your middle term, factor by grouping, all that jazz. Any questions before we get started? Okay, so we've got 2 examples to do. This is how we were factoring back in 5.9. So if you need more examples or more in-depth steps, 5.9, notes and assignment, and the video that's still on the agenda are the places to go if you need more review of this. Okay, so this is my A, B, and C. I'm going to put it over here. I'm going to use my little baseball diamond / Magic X, whatever you want to call it. A times C is 2 times 21. What's 2 times 21? Double 21. Yeah, 42. Okay, so I am trying to multiply to 42. I am trying to add to 17. 17 different options of how you can do this. Not actually. You can write out all your factors if you need to. I like to sometimes, if I don't know my factors off the top of my head, I know 42 divided by 1, so 1 and 42, 42 divided by 2, 2 and 21, 42 divided by 3, 42 divided by 4, 42 divided by 5, 42 divided by 6. And so now I have all my options, okay? So all of my options, I'm looking for the ones that add together. Oh, that's from yesterday. Add together to be 17. So 1 and 42, no. 2 and 21, no. 3 and 14, those add together to be 17, okay? So 3 and 14 are going to be the numbers that I use to split. So that's what you guys were just doing at the boards around the room. That's why we did that for so long, for like the 4th time. So once we figure out those two numbers, we use those to split that 17x. So we're going to keep our 2x squared as is. We're going to split up our 17x. And instead of having 17x, we're going to have 3x and 14x. And then we also have our 21. Okay. Any questions at the moment? Okay, so then we are going to factor this by grouping. Out of 2x squared and 3x, I cannot divide 2 and 3 by anything, but I can pull out an x. So I'm going to pull out an x. That's going to leave behind 2 and the other x. And then 3x divided by x leaves behind a 3. What can I divide 14 and 21 both by? 7. So 14x divided by 7 is 2. Still have my x. 21 divided by 7 is 3. Okay. And then from there, I can write my factored form. So my 2 sets of parentheses match. That's going to be one part of my factored form. And then my x plus 7. So my x comes from right there, and my 7. So those are my 2 GCFs. They make the other part. Okay. Any questions right now? Okay. From here, we are now still using the zero product property. So we set this equal to 0, which means I need to set each of my factors equal to 0. So we will have 2x plus 3 equals 0. We'll solve that out. And we'll have x plus 7 equals 0. We'll solve that out. So solving out 2x plus 3, I'm going to subtract 3 from both sides. I get 2x equals -3. And I divide both sides by 2. I'm going to get x is -3 halves. So that is one of my zeros. The other one's way easier to solve out. X plus 7 equals 0. I just subtract 7. And I get x is -7. Okay. Any questions on either of those guys? Or on that guy? It's one whole problem with 2 answers at the end. Okay. I want to show you guys, you can check your answers to these. So let me zoom out. I would do it in my calculator, or I would never check an answer to this in my head. But if I were to plug this in, I would do, now I need to get all this chaos off my calculator. 2, open parentheses, -3 divided by 2, close parentheses, squared, plus 17 times -3 divided by 2, close parentheses, plus 21. I hit enter. I get 0. And then I could do the same thing with -7. 2, open parentheses, -7, squared, plus 17 times -7, plus 21, enter, 0. You guys are doing a lot of advanced math. And if you were to plug in these really complicated answers to this really complicated function, you would get 0 for both if you haven't made any mistakes. All right, we've got one more we're going to do together, and then we'll have the rest of class to work on our assignment. So we've got 6x squared minus x minus 12. Any questions right now? I didn't really ask that after that one. Any questions? All right, so let's go through that same process. So we are trying to multiply to be AC. So I've got my A, my B, and my C. My AC in this one is 6 times negative 12, which is negative 72. So I'm going to multiply to negative 72. Next question, what's my B value? Negative 1. So there's an imaginary 1 there. Negative 1 is what I'm trying to add to. Okay. So then we're sitting here, we're saying, I need to multiply to negative 72. I need to add to negative 1. So that means that the numbers that are going to multiply to 72 only need to be 1 apart from each other, and only can be 1 apart from each other. What are factors of 72 that are close together?
8 and 9.
9 and 8, 8 and 9. You guys got it. So I'm going to put down 8 and 9. Which one do we need to be negative? The 9, because we want the bigger one to be negative so that they add to be negative. Awesome. Okay, so from there, we can split our middle term and factor. So 6x squared stays 6x squared. Negative 1x is splitting up into 8x, so plus 8x, minus 9x, and then I still have my minus 12. All right, 6x squared plus 8x. What can we divide 6 and 8 both by? 2. I can also pull out an x. So 6x squared divided by 2x. 6 divided by 2 is 3. X squared, take away one of the x's, leaves behind the other x. 8x divided by 2x is 4. Cool. Negative 9x and negative 12. What can I divide both of those by? Yeah, so I can divide them both by 3. 9 and 12 you can divide by 3. But since they're both negative and I want to leave behind positives, I want to divide out a negative 3. Anytime that third term there, 1, 2, third term is negative, you're going to want to do a negative GCF on that second set. So negative 9x divided by negative 3 leaves behind positive 3x. Negative 12 divided by negative 3 leaves behind positive 4. And then we're going to have 2 sets of parentheses. So we will have 3x plus 4 and 2x minus 3. So 3x plus 4 is the matching ones. And then the 2x minus 3 comes from those 2 GCFs. Okay. Any questions at the moment? Alright, so then we'll set each of those equal to 0. 3x plus 4 equals 0. Solve that. I guess I can set it equal to 0 here too. Subtract 4 from both sides. 3x equals negative 4. Divide by 3. And my first answer is going to be this negative 4/3. Leave it as a fraction. And then for my other guy, I'm going to do the 2x minus 3, set it equal to 0. I'll have to add 3 to both sides. So I'll get 2x equals positive 3. And I can divide both sides by 2. I'm going to get x is 3 halves. Okay. Any questions at the moment?